What's up, everybody? It's Dan from SageMathTutoring.com, and here with another video. This time it is a calculus video where we are going to be discussing the ways to compare functions, the first derivative, and the second derivative graphs. This is a subtopic in calculus that can be very confusing, and it's confusing for me as well, actually. I just worked with a student earlier. Some of the problems that he was faced with, I had to really think about. And I was thinking to myself, well, it would be awesome if we just had a one-stop reference guide that really shows you the ways in which these graphs relate to each other. That would be the original function, the first derivative, and the second derivative. And I think I cobbled together something that could be potentially a game changer. I don't think I'm the first to have attempted this. Upon a quick Google search, I did see some sort of tables that sort of related the various graphs to each other. But I feel like this one might be my favorite one out of all of them. So feel free to screenshot this if you think it would be helpful to you. Obviously, there's some small writing here. So if you want to screenshot it, screenshot this part maybe, and then maybe screenshot this information. This is kind of extra information down here. I'm going to ignore the extra information for now, and I say we just kind of talk about these top three rows. First, obviously we can see that we have the original function, we have the first derivative, and we have the second derivative. I'm actually going to begin by talking about the relationship between the second derivative and the original function first, okay? Now, many students watching already know that when the second derivative is greater than 0, also known as above the x-axis, well, that means that the original function is concave up. Many of my students watching, or many students in general watching, know that when the second derivative is below the x-axis, also known as negative, then the original function is concave down. What is not mentioned as often is the relationship between the second derivative graph and the first derivative graph, where when the second derivative graph is greater than 0, well, we should know that the first derivative graph is increasing, meaning the slope is positive. When the second derivative graph is less than 0, we should know that the first derivative graph has a negative slope and is therefore decreasing. But then we get into the sort of weird nuances, okay? Now, let's say the first derivative graph is increasing, meaning it has a positive slope. Well, it's still the case that it's either below the x-axis or above the x-axis. Even if it's increasing, well, it's either below the x-axis or it is above the x-axis, right? Well, this is something that many students definitely know, which is that when the first derivative is negative, when the first derivative is below the x-axis, well, that means that the original function is decreasing. Many students know that. When the first derivative is above the x-axis, many students know that the original function is increasing, right? But let's look at this purple thing. Let's say the first derivative graph equaled 0, but on the left it was negative, and on the right it was positive. So it's almost like the first derivative graph was negative, and then it went through the x-axis, and then it became positive. Well, that's how we know we are dealing with a decreasing changing to an increasing, okay? And we're dealing with a valley, or at the very least, a local minimum, okay? Now, there is a scenario where the function could go from negative to negative and from positive to positive. That's what that section below is all about. We're going to talk about that later, okay? So hopefully this all makes sense. My goal right now is to just make it so that you sort of understand what I'm even saying here, okay? So I think many students would realize that this is just vice versa. When it's the case that f prime of x is decreasing, well, it's still possible that it's above the x-axis. It's still possible it's below the x-axis. If f prime of x is above the x-axis, also known as positive, then the original function is increasing, also known as having a positive slope. When f prime of x is less than 0, also known as negative, then the original function is decreasing, also known as having a negative slope. That is something that most students recognize, even when they're doing things like the first derivative test. Now, getting into further nuances, If it's the case that f prime of x actually equals 0, but it's switching from positive to negative, meaning the graph of f prime of x was above the x-axis, then it went through the x-axis, and then now it's below the x-axis, it is then the case that we have a local maximum happening here, okay, when it comes to this purple thing. This purple thing means that this purple thing stands for this purple point here, where it goes up and then it goes down, okay? So that's that. We'll get to the strange case later. Let's look at this last column here. And once again, we will actually begin by discussing the relationship between f double prime of x and f prime of x. So let's take a look. When f prime of x equals 0, that's also known as an inflection point. And it's either the case, when you do the second derivative test, many students are used to finding the critical values, those x values where there is indeed an inflection point. Now, an inflection point is when it changes from negative to positive, okay? Or positive to negative. Now, it is the case that when we have this yellow point on f double prime of x graph, where it's crossing the x-axis and it switches from negative to positive, well, that means it switched from concave down to concave up on the original function. And vice versa is true over here. If it's the case on the graph of f double prime of x that it went from positive to negative, then it went from concave up to concave down. So many of my students watching, and many students in general watching, recognize that from the second derivative test. Once again, what is less talked about, perhaps, is the relationship between f double prime of x and f single prime of x, which is that when f double prime of x equals 0, which is this yellow point here, and it goes from negative to positive, well, then we have a negative slope and a positive slope here, meaning that we have a valley situation, also known as a local minimum. Notice how this yellow point represents the demarcation line about which all of this is occurring. Everything that's on the left here applies up across the board. Same with this all applies across the board, okay? So if f double prime is positive, well, we have a positive slope here, but we also know that this part is concave up as well. So I think you get the gist of that. Now, over here, of course, it's vice versa. So if f double prime of x equals 0, that's the yellow point, and it goes from positive to negative, well, then we have a positive slope here in f prime of x and a negative slope. So we have this sort of peak here, also known as a maximum or a local maximum. So that is the case. It's really this that you're going to have to deal with most of the time. There is this sort of other scenario where I want to be thorough and mention, and that is this bottom part where if any of the function, and when I say a function, I mean not even necessarily the original function. I mean if any of these equals 0, but it goes from positive to positive, such as this yellow point crosses the x-axis. That's why the function equals 0. But it goes it's above the x-axis here and it's above the x-axis here. Then the function above it looks like this. Okay, when I say the function above it, I mean if you have this scenario happening with f double prime of x, well, then the function above it, meaning f prime of x, looks like this. So I want you to just remember that this scenario where you have, we could say, a valley, but the vertex of the valley is on the x-axis, then the function above it looks like this. Okay, so that's sort of a strange case scenario, and vice versa is true, where if a function equals 0, like right here, but it goes from negative to negative, meaning it's below the x-axis here, and it's also below the x-axis here. So in other words, it's like a peak, but the peak is actually hitting the x-axis. Well, then the quote-unquote function above it looks like this, okay? So that should be very useful information. Let's kind of put it to the test and see what's going on with a couple practice problems. Okay, so looking at this one here, the plot below shows y equals f prime of x. So already we are in the second row, aren't we? Right? So let's take a look at what's going on. Which of the following functions is the graph of the original? So in other words, we're here and we want to know what's going on up here. Well, first of all, we have this moment here where it's clearly below the x-axis, and we have this moment here where it's clearly above the x-axis. So in my opinion, we should immediately have our attention drawn to that. Now, it's going from negative to positive. Well, that is denoted right here, where it goes from negative to positive, right? So we know that there should be sort of a valley scenario, right, in the original function, where it goes from negative to positive, and the so-called vertex of that valley is going to be the place where it actually crossed from negative to positive. So let's take a look at what that is. Well, that looks like it's that. To me, that looks to be about negative 1.5. Now, believe it or not, that might be enough information to know the answer. We just need to look at a multiple choice answer where there is a U shape like this that's occurring about the x-axis, or the x value of negative 1.5. So I feel like these answers are gone because we don't have a U shape. We have a mountain there. We don't have a valley. We have a mountain there. This is gone as well. Now, these are kind of interesting, right? Let's see. I mean, at negative 1.5, there kind of is sort of kind of maybe a little bit like a U. I don't know. Definitely more of like what I would have expected right here. But my attention is being drawn to the fact that, in a way, this graph, of the two answer choices we're left with, this one kind of looks like this one, doesn't it? It's got a similar swoopy thing going on, but this is more of like a sharp valley, whereas this is kind of flat. But this is like a sharp mountaintop, whereas this is kind of flat. Now, my sense is that, if it's flat, that means, and this is, again, the graph of the original function, but if it's flat, that means that the slope is kind of like zero for a while. The slope of the derivatives, or the slope of the original function is zero for a while. The slope of the original function is zero for a little while. It kind of looks like that, right? And that means that the graph of f prime of x had to have equaled zero for a while, right? Because the graph of f prime of x, whatever the y value is, or whatever the f prime of x equals, is the slope of the tangent line of the original function. So the slope of the tangent line of the original function is zero here for a while. Well, this is not, the graph of f prime of x is not hanging out at the x-axis for a while. But I'll tell you what, it is kind of hanging out on the x-axis for a while here, which means that the slope of the tangent line of the original function has to be sort of zero for a while, and that is happening here. Okay, so in other words, in the graph of f prime of x, it quickly passes through the y value of zero here, and that's what's happening here. It quickly changes direction, whereas it kind of lingers on the x-axis here, which means that, this is once again the graph of f prime of x. It kind of lingers on the x-axis here, meaning that it equals zero for a while, which means that the slope of the tangent line of the original function is going to be zero for a while here. So that is most definitely this as the answer. Okay, so hopefully that makes sense. Okay, looking at this one, let's bring in our reference guide right now. What are they saying? The plot below shows the graph of f prime of x again. Okay, so once again, we are in the second row. Which of the following gives us the graph of f double prime of x? Okay, so now we're looking at the relationship between f prime of x and this. Now, I'm going to say clearly whether or not f prime of x, the original graph, is increasing or decreasing matters. So what I'm going to do, believe it or not, is I'm going to label in green all the areas where f prime of x is increasing, And I'm going to label it in red all the areas where f prime of x is decreasing. So it's increasing here. And actually, that looks like that's all there is to it, right? So decreasing, not decreasing here. So there's a hole there. Maybe there's actually a hole over here. And then it's decreasing again, right? I'm wondering if we can just use that, okay? Now, let's remind ourselves, wherever f prime of x is decreasing, f double prime of x has to be below the x-axis. Wherever f prime of x is increasing, f double prime of x has to be above the x-axis. So let's look at the green area and ask ourselves, which graphs are such that, you know, it really looks like between the x values of negative 2.5 and that really looks like negative 0.5, I should say. Which answer choice is such that between the x values of negative 2.5 and negative 0.5 is the graph above the x-axis, okay? So clearly not this one, clearly not this one. It does indeed look like this is a contender. Yeah, so these are both contenders right here. These are contenders. So what I'm going to do is I'm actually going to bring these up so that they're a little closer. And we're going to really analyze these, okay? So there is, of course, a temptation to relate this phenomenon with this phenomenon, right? But here's my thought about that. We need to be careful. Well, some of you might be catching it, but this is a case where a mountaintop hits the x-axis and then goes down again. Now, I already discussed that here, where you have a mountaintop hitting the x-axis and then going down again, and I told you that the graph above it looks like this. Well, that is what's happening here, right? You see this shape here? That is what's happening here. So it is for that reason. The fact that f double prime of x, let's be very clear, f prime of x is above f double prime of x. F prime of x is above f double prime of x. So, you know, I'm throwing in with this as the answer because of that phenomena where it grazes the x-axis. That is this right here. And I told you that the graph above it looks like this. Okay, it looks like this. Okay, now we could get into why that is. Okay, I don't really want to do that in this video. That is interesting. I actually do think that's worth being clear about. But I want to make this video more for the purpose of providing you with a reference guide that just sums it all up. Okay, so that's that. Okay, so looking at this one, the graphs of f prime of x, and f double prime are given below in no particular order. Identify which graph is which. Okay, so let's take a look. I'm going to say, why don't we try to spot f of x first, and we'll just pay attention to these phenomena here. Right? So, if you have this, and it was the case that this is f of x, well, then let's actually look for f prime of x. This is concave up clearly, which means that f prime of x has to be positive there. Now, I'm not seeing that here, because here's the x-axis, right? Here's the x-axis, by the way. I'm not seeing this being positive above the x-axis. And also, I'm not seeing this entire thing be positive over that interval, right? Because it needs to go, to about here. So this goes from positive to negative over that interval. So we know for sure this can't be f of x. So I say we stick with this strategy of just looking for f of x based off of literally that information, okay? Namely concave up, concave downness. Let's focus on concave up, right? So this one really seems like it's concave up here between the values of, 4.5 and we'll just say 8. That's fine. Which means that between 4.5, if it's concave up, that means between 4.5 and 8, f double prime is going to be above the x-axis. So let's see if that's happening anywhere. Yeah. Yes. Yeah, this is above the x-axis from 4.5-ish to 8-ish. Now, let's be very clear. We estimated this. It's not exactly 4.5. For all we know, the point of inflection is a little bit past 4.5. This, for all we know, the point of inflection is a little bit less than 8. So these are estimates, right? So far, we are building a case that this is f of x and this is f double prime of x, right? Now, that would make this potentially, f prime of x? Maybe. I don't know if we need that equal sign. I don't think we need that. So we know that when the slope of f of x is increasing, f prime of x is above the x-axis. Okay, so the slope of f of x, if this is indeed f of x, is increasing here. But is f prime of x above the x-axis during that interval? No. So therefore, we know beyond a shadow of a doubt that this second one cannot be f of x. Now, that means, of course, that the third one is f of x, okay? So we will go ahead and just with confidence call this f of x. Now, let's stick with concave up, concave downness. This thing is concave up basically from here to there, and that appears to be 1.5 to, let's call it 4.5, all right, knowing that it's an estimate. Now, since this is concave up from 1.5 to 4.5, we want something that's above the x-axis as f double prime. That is most definitely happening here, so this has to be f double prime of x because it's above the x-axis from here to here. Now, let's also focus on positive slope. This has a positive slope from here to there. Now, to me, that looks like it's from 3 all the way to like 6.2 or something, right? So we are now looking to confirm that this third one is indeed above the x-axis from approximately 3 to 6.2. Well, indeed, it is above the x-axis from approximately 3 all the way to about 6.2. So that is happening there. So we know that that's f prime of x. Now, all of the information that you needed for that was in the reference guide. So anyway, hopefully that helps everybody, and I will talk to you later.